Hello class, for this video lesson, we are starting with a new topic and this is unit 1.8 in the syllabus and this unit is all about pressure. What can you expect in this unit? We're going to learn about pressure in solids, pressure in liquids, and also pressure in gases. So we're going to start off with the basics of pressure first, pressure on solid surfaces. What is pressure? So you probably heard of the word pressure before. Here are some examples of where you might have heard this word: water pressure, air pressure, high blood pressure, and also pressure from work or school. So when you think about the word high pressure, what does it mean to you? Right? So you might think that, oh, high pressure means it is something strong. What about the word low pressure? What does it mean to you? So low pressure means weak. So from these two things alone, we can kind of get the idea that pressure somehow is related to force. When there is high pressure, it's sort of like there's a large force happening. When there is weak pressure, then the force is weak. So pressure is related to force, but it is a bit different. Now here's another way to look at pressure. So try poking your friend with one finger or try poking your own body with one finger. When you are doing this, your finger is exerting pressure to your friend's skin or to the skin. And then try doing the same thing, but now instead of using your finger to poke, you use your palm, but you do it with the same amount of force. So which one hurts more? Or which one is more annoying? So your friend will feel that poking with one finger hurts more or is more annoying. That means poking with one finger exerts a larger amount of pressure because you can feel the hurt when compared to the palm. So the palm doesn't hurt so much, doesn't exert a lot of pressure. So when you're doing these two actions, you're not really exerting too much force. You are giving the same force. You're pushing the finger and the palm in the same way, but why do they feel different? One has more pressure and the other. What is the difference between using one finger and the palm of your hand? And the difference is in the surface area. The tip of your finger has a smaller surface area than your palm. So if this is the surface and this is your finger and this is the surface and this is your palm, right? The area in which your finger is in contact with the surface is only this small, whereas for the palm, the area in contact with the surface is quite large. So it's this whole area here. This is how much of the surface that is in contact with the palm. So pressure is related to area. If the area is smaller, like the poke of the finger, right, then it will exert a higher pressure than if the area is bigger. If area is bigger like the palm, then you don't exert as much force. Now, you should realize that pressure is related to these two things, force and area. And therefore, we can define pressure using these two factors. Pressure is the force per unit area. So in other words, how much force is given to a certain amount of area. Now, from this definition, we can calculate pressure is equal to force per area. So force over area. And pressure, of course, has a unit, and this unit is newtons per meter square, or PA, which stands for Pascal. And as you can probably guess, the scientist that was studying about pressure was a scientist called Pascal. And the unit here comes from the formula itself. So the unit for force is Newton, and the unit for area is meter square. And if you write it down like this, and that's where the unit comes from. So pressure can exist between solids, in liquids, and also in gases. Let's do example 1 to show how pressure works. So a person is trying to walk on snow and will find it difficult because his feet will always duck into the snow. So if you are walking on snow, and especially if the snow is thick, when you are trying to walk on it, your feet will sink into the snow. Say if the total surface area of her feet is 3 meters square and her mass is 60 kilograms, what is the pressure done by her feet onto the snow? Okay, so this is the snow and this is the feet here. The surface area is 3 meters per second. So that is the area in contact between her 2 feet and also the snow. And she has a mass of 60 kilograms. Now, if you want to find pressure, we use this formula. Pressure is equal to force over area. And what is the force that this person exerts on the snow? In order to find the force, we look at the mass, right? So she has a weight. Therefore, from the mass, we can figure out the weight or the force exerted on the snow. So weight is equal to mass times the gravitational field strength. So it's 60 times 10, and her weight is 600 Newton. So the force exerted on the snow is equal to the weight of this person, and it is 600. What about the area? The area is 3, and therefore if you calculate everything, that will give a force of 200 Pascal. So because it's hard to walk on snow, your foot or your feet will dug into the ground whenever you try to walk on it. She solves this problem by using something called snowshoes. Using the snowshoes, the surface area of her feet is now 6 meters square. How does this affect the pressure on the snow by her feet? So the snowshoe, as you can see here, has a wider surface area. So before it's 3 meters square, now it's 6 meters square. So what's the pressure now? Again, we'll use this formula. What is the force exerted on the snow? The force is her weight, and her weight is still the same, 600 Newton. The area now is larger. It's now 6 meters square. So 600 divided by 6, and that is 100 Pascal. So she has a smaller pressure now. In other words, her feet exerts a smaller pressure on the snow, and therefore because of the smaller pressure, her feet doesn't go into the snow. So her feet doesn't exert that much pressure onto the snow, and she can walk on snow without digging into the snow. Let's look at example 2. So here you have someone doing a performance, and this person is lying down a bed of nails. So performer states that he can lie down on a bed of nails and would not get any serious injuries. The bed of nails is made out of 5,000 nails placed very close to each other. Each nail has a surface area of 0.05 meters square. So if the skin of a normal person could withstand a maximum pressure of 4 Pascal, how would this performer be able to complete this act if his mass is 50 grams? So you lie on a bed of nail, but the nail doesn't penetrate into your skin. So you are still safe from this performance. How is that possible? And we can explain that by using pressure. So, even though this stunt looks dangerous, but if you calculate the pressure, you will find that the pressure is not very high. So, let's do that really quickly. So, pressure is equal to force over area. So, when this person is lying down, what is the force that this person exerts on the bed of nails? It is his weight. Let's quickly calculate his weight. He has a mass of 50 kilograms. That means his weight is 50 times 10. He is exerting a weight of 500 newtons to the bed of nails. What about the area? So we have 5,000 nails, and each nail has a surface area of 0.05. So if you look at that, let's say this is this person here, this is the person, and this is the nail, right? So one nail has a very small surface area, which is 0.05, but all together combined, what is the total surface area that is between the nails and this person? So it is 5,000 times by 0.05. That is equal to 250 meters square. So 250 meters square, and we calculate that, and the pressure is 2 Pascal, right? So you can see from this stunt here, there is actually a large surface area that is in contact between this person and the bed of nails. So because of that large area, the pressure exerted on this person is very small. In fact, it's smaller than 4 Pascal, and therefore the bed of the nails do not puncture into this person's skin. So this stun is actually quite safe. Now, if you have only one nail and this person is lying on one nail only, that nail has a small surface area, and because of that small surface area, that produces a large pressure. And when there is a large pressure, the nail can easily go through this person's skin and this person is going to get injured. So to summarize, the reason why this person is safe from this stun is only because of the area. The area is large and the pressure caused by it is low. So why must he lie down? Why can't he just stand on that bed of nails? If he is lying down on his back, his body will exert a small pressure. This is because his whole body is at a position where the surface area is the greatest. So if he is standing up instead, what's going to happen, that's his feet, the surface area will be small in this case, and because the area in contact is small, that causes the pressure to increase and there will be a large pressure, and this will be a much more dangerous stunt to do. Example 3, let's look at cars and how cars and their tires can exert pressure on the ground. A tractor of mass 300 kilograms can safely go through soft soil areas, but a normal 1000 kilogram car would be stuck right away. Why does this happen? Okay, so this tractor, even though it's heavy, it can go through any terrain, any ground, even though the ground is soft. But if it's like a normal car, the normal car will get stuck. So the answer is in the tires. A tractor, even though being heavier, uses very wide tires. And because the tires are wide, that means the tire has large surface area and therefore the tires exert low pressure. And therefore the tires don't dig into or cut into the ground, and so the heavy tractor can go through the ground quite easily without sinking, without getting stuck to the mud. Let's show this using calculations. Let's say a normal car tire usually has a surface area of 0.5 meters square, but a tractor tire would be many times as large, 2 meters square. So doesn't seem much difference. Let's try calculating the pressure and see what is the difference between the two pressure. So here on the left side, we'll do the one for the car, and on the right side, we'll do the one for the tractor. Okay, let's calculate the car first. The car, this is the formula we use. And the force of the car exerted on the ground, what is the force? The force is equal to the weight. So in the car's case, the weight of the car is equal to, it has a mass of 1000 and therefore it has a weight of 10,000 newtons. What's the total area of the car in contact with the ground? One tire has a surface area of 0.5. Therefore, if you have 4 tires, one car has 4 tires, so the total surface area in this case is 2.0 meters per second. So divided by 2.0, that's the total area. And that will give us a pressure of 5,000 Pascal for the car. What about the tractor? So let's calculate that one. It's the same calculation. The force of the tractor exerted on the ground. So again, this force is equivalent or equal to the weight. The mass of the tractor is very heavy, 3,000. So that will give a weight of 30,000 Newton for the tractor. What's the area? One tire has a surface area of 2 meters per second and a tractor has 4 tires. So overall, in total, the tractor has a surface area of 8 meters square. So 30,000 divided by 8, that is 3,750 Pascal. So you see, thanks to the big surface area of the tires of the tractor exert less pressure on the ground, so the tractor doesn't cut into the ground or doesn't dig into the ground as easily as a car would be. Okay, to summarize, we looked at pressure and its definition. So pressure depends on how much force is given per unit area, and the formula of pressure is force over area. And then we looked at how we can change the surface area in order to change the pressure. So if the area is small, the pressure is high. And if the reverse, if the area is big, then the pressure will be low. Okay? In the next video lesson, we'll be looking at pressure in liquids.